During my presentation, I will tell you a bit on of ARN, also on the EOV directive, and also the upcoming challenges for the automotive recycling sector when all these new materials are used in cars as well. So first, ARN. Well, ARN is founded in '93 and is active since '95 as a collective compliance system, with the main objective is the extended producer responsibility within the end-of-life vehicles directive, and also since 2008 the compliance system on the batteries, namely the ARN management plan. So ARN got 4 stakeholders representing the Dutch automotive sector and manage a voluntary recycle system on behalf of these producers and importers. So when you buy your new car, you will pay a recycling fee, and with this fee, this supports the non-profitable dismantling and recycling activities. The fee is now for a new vehicle 30 euros per car, and if the car also has an EV battery, then there will be an additional recycling fee, which is weighed on the weight of the battery. So what's the key of the success of this implementation and execution of the end-of-life directive in the Netherlands? That is the registration and deregistration system. So when you buy a car or a car is imported in the Netherlands, it needs to be registered at the RDW. And there is a link between the vehicle registration and the vehicle tax. And the only one of the possibilities to end this obligation is to deregister your vehicle at the car dismantler or authorized treatment facility. And if you do not deregister, the last owner will remain liable for the vehicle taxes of tax. It's also possible to suspend your car, but this costs you a yearly fee. So still there is at the end an incentive to deregister your car. And ARN got access to the data, and with that data, ARN can monitoring the Dutch end-of-life recycling chain. And this unique combination between the license and the vehicle makes the Dutch end-of-life vehicle in the Netherlands traceable. So what happens when a car is end of life? Well, first of all, a car can be end of life when it is no longer adding value to the owner, or premature when it is end of life by an accident. So after it's deregistered at the car dismantler will depollute the car and of its hazard materials. This is like oil, fluids, coolant, but also the starter battery or the EV propulsion battery. And for safety matters, ARN developed together with Innovam a training that learned the dismantlers how to dismantle the end-of-life battery safely from a car. Also, the dismantler will take all the value parts and parts for the second-hand market. After the car is dismantled and depolluted, it will end at the end at the shredding company, which will shred the car in small pieces and metal will be separated. What's left over is ASR, also called automotive shredder residue. This is being treated at the post-shredder technology plant in Tiel. This plant is built by ARN, and last year it's sold to a shredder company in the Netherlands. At the PST, the shredder residue, automotive shredder residue, is further processed, and the output consists of 4 main materials. It's minerals, fibers, plastics, and metals. And these outputs are then further processed or used as secondary raw materials in products. So the end-of-life directive. Since the end-of-life directive says that all the member states need to recycle the car, and since 2015, the reuse and recovery is set above 95% of an end-of-life vehicle. The end-of-life directive is since 2000 and is implemented in 2002, but because it's a directive, every member state can put its own implementation. And in the Netherlands, this is set as a besluitbeheer autovakken. Well, in the Netherlands, the recycling of the end-of-life vehicles is with a shredder campaign that is conducted every 5 years. Also, we have a yearly recycling performance, and ARN conducts mass balance at the car dismantlers. But also, we have an audit tool that can be used with recycling companies, and where you can where there's focus on the financial cost and on the carbon footprint and on the recycling performance. So with that, you can choose between what is the performance on finance, but also on the recycling, where you will recycle the materials that are dismantled from a car. And also, very important is the recycling network in the Netherlands. We have 214 dismantlers that is connected to ARN, and we have around 15 shredders, of which 7 in the Netherlands and 1 PST plant, together with all the companies that do the transport and recycle the material after it's been dismantled or treated at the PST. Together with all these partners, we succeeded in the year 2019 a recycling performance of 98.4%. And on the right, you can see that 24% is being established at the car dismantler, 60.3% is established at the shredding company, and 14.1% is established at the PST plant in Tiel. Well, these results are the results we have now, but what are the challenges that are upcoming in the automotive? Well, first of all, it's the composition of a vehicle. It's already mentioned in a couple of presentations, the use of lightweight materials, also composites, and the higher amount of non-metals. But also the joints and how parts are glued together makes it difficult to separate materials from each other for recycling. All these things have an advantage on the environmental impact during lifetime, but can give some challenges in the recyclability of a vehicle. Now, if you look at safety, now we can see that there are lithium starter batteries used in vehicles instead of lead. Well, from the outside, they don't differ very much. They look almost the same. But when a lithium battery goes into a lead recycling chain, this can bring some threats, fires and explosions. And if you look a bit on the financial side, and then we focus on the propulsion battery of lithium, batteries has a lot of different chemistry, but also dimensions, and the encrypted battery management systems makes it rather difficult to see the state of health. And also for the recycling process, the quantity and continuity of the available end-of-life batteries makes it a challenge how you will fill in your recycling process, and the determination of the battery classification. From the outside, you cannot see what's happened inside the battery. So if it's stable or if it's not stable. So if you're not sure what the condition is, you will set it as an unstable. You will treat it as an unstable battery, and this brings additional costs in transport and handling. And the last challenge I want to point out is the regulations. Now there's a revision of the end-of-life vehicle directive, and plausible is that there will be a minimum quota on the plastic recycling within a car. For now, it's at this moment it's 0, but in the new EOV directive, it will be plausible that this will be taken into account. Also, if we look at the batteries, the battery directive will now turn into a regulation. instead of a directive. So there will be more strict rules in the recycling and processing of these batteries. Also mentioned earlier, but is also unknown, is the emission targets of the vehicles. Will this bring more electrification or the use of materials? These will also have an impact on the recycling of end-of-life vehicles. And at the end, also, or the last point, is the POP regulations. The cars that we are now recycling as end-of-life has an average age of 18 years. So when they were produced, other materials are used than we use now in vehicles. And perhaps these materials are set later on the subsistence of very high concern. Well, this is makes it difficult, or sometimes perhaps impossible, to use these materials as in new products as a recycled material. So this was my last slide of my presentation. I want to thank you for your attention. And which questions do you have for me?